Ötesinde Tasarım Kâşiflerine hoş geldiniz. Bizim bu yolculuğumuz 7 sene önce, 2013'te Yapı Endüstri Merkezi ile başlamıştı. Son 2 yıldır da Arkitera ile devam ediyoruz konferans serimize. Ben hem Yapı Endüstri Merkezi'ne hem de Arkitera'ya, hem sektöre hem de bize katkılarından dolayı çok teşekkür etmek istiyorum. Her yıl iletişim temamız doğrultusunda belirlediğimiz temalarla kendi alanında çığır açmış çok değerli konuşmacıları ağırlıyoruz. Bu seneki konuğumuz da strüktür tasarımına getirdiği inovatif çözümlerle çığır açan Profesör Hanif Kara. Ben kendisine burada bugün bizimle olduğu için çok teşekkür ediyorum. I would like to thank you for being here today with us, for accepting our invitation. Profesör Hanif Kara'nın çok özel bir ricası var bugün bizden. Bugün bizimle paylaşacağı bilgilerin gizliliğinden dolayı sunumunun kesinlikle videoya çekilmemesini rica ediyor. Bu nedenle bu konuda hassasiyet gösterirseniz çok teşekkür ederiz biz de. Ben öncelikle sahneye Genel Müdürümüz Sayın Ufuk Algayer'i açılış konuşmasını yapmak için davet etmek istiyorum. Ve sizlere de katılımınızdan dolayı çok teşekkür ediyorum. Keyifli bir konferans diliyorum.
Teşekkürler Seçil Hanım. Değerli basın mensupları, sevgili konuklar. Bu yıl 7.sini düzenlediğimiz Zamanın Ötesinde Tasarım Kâşifleri etkinliğine hepiniz hoş geldiniz. Bu yıl 7. yılımız ve 7 yıldır farklı disiplinlerin nasıl bir araya gelebileceğini ve bir bütün haline gelip nasıl mimariye değer katacağını hep birlikte izledik, konuştuk, masaya yatırdık. Geberit olarak 2019 mottomuzu bir adım önde, ilk günden beri olarak belirledik. Hepinizin bildiği gibi iyi bir tasarım mimariye değer katar. Bu da tasarımınızın farklılaşmasına, tasarım dünyasında bir adım öne çıkmanızı sağlar. Biz bu noktada tasarımı fonksiyonla buluşturuyoruz. Tam 150 yıldır inovasyonu marka değerlerimizin merkezine koyduk. Bu bakış açısıyla da sektörde önemli başarılara imza attık. Şimdi de 150 yıllık duvar arkasındaki profesyonelliğimizi 2020 yılının başı ile birlikte Türkiye'de de duvarın önüne taşıyoruz. Artık Türkiye vitrifiye ve banyo mobilyaları pazarında birbirinden değerli banyo ürün ve mobilyaları ile biz de varız. Ürünlerimizi hemen Ocak ayından itibaren tüketiciler ve profesyonellerle buluşturacağımız haberini bugün burada sizlerle paylaşmaktan çok mutluyuz. Değerli konuklar, Geberit olarak ödünsüz kalite anlayışımızla ürünler geliştirdik ve geliştirmeye devam ediyoruz. Bu kapsamda Zamanın Ötesinde Tasarım Kâşiflerinin 7.sinde mimarlık ve strüktürel tasarım kavramlarını bir bütün olarak ele alan Profesör Doktor Hanif Kara ile karşınızda olmaktan oldukça mutluyuz. Yeni bir çirkinlik çağında tasarım mühendisliği ile ufak tefek yenilikler başlıklı konuşmasında Profesör Kara, strüktür tasarımına getirdiği inovatif ve yenilikçi çözümler ile mimarların kendi sınırlarını her geçen gün daha da zorlamasına yardımcı olduğunu detaylarıyla bize aktaracak. Profesör Doktor Kara'nın anlatacaklarının hepimize ilham kaynağı olacağını inanıyor. Daha fazla vaktinizi almadan sahneyi ona bırakmak istiyorum. Katılımınızdan dolayı yeniden size teşekkür ediyor. Hepinize keyifli bir akşam diliyorum. Teşekkür ederim. Profesör Kara, now it's their turn. Please. Nice to see you.
Thank you very much. Thank you.
Please.
Okay. Good evening, everyone. Thank you for showing up, so many of you, in an evening like this. I want to first thank, on behalf of all of us, Geberit for sponsoring this. to sponsor knowledge and conversation and dialogue is becoming very unusual. So I'm really pleased that they still take the initiative to invite people to talk about this. I want to thank also Arkitera for making the whole thing really smooth, and today I spent a lot of time with the media, with a lot of apprehension, but I have to tell you, your media is excellent. So these are the things that I feel very comfortable about. I was told to talk about minor or innovations rather than really design, but I'm going to use the opportunity to use two words quite often, the word minor and the word ugliness, and I'll try and explain that through the work. I started to think about innovation quite some time ago when I started my office, and I realized that, my machine is stopped, but I'll look there if you don't mind. I realized that the rate of innovation is slowing down if you look back long enough. If you look back 4,000 years, and you really can't look that far back in many places of the world, but in this city, it's quite easy to look back at the innovation. And what you discover very quickly is, despite the fact that you, the very young generation, and my generation also thought that innovation was happening very quickly with internet, my opinion is that large-scale innovation is very slow in happening. What we're getting is minor innovations. Now, what does that mean in architectural terms? There is a way of kind of checking this out. I would say to you that in your city, for example, you have visibility of the rate at which architecture has changed and why. So when I look at the way you have given, architects have given people like me a life, I see very quickly that when life became difficult for you from that left-hand model where the elephant was carrying the man, you had to give people like me your task, give up your job, and get people like me to do this job. This only happened maybe 200 years ago, so engineers were born around about then. What has happened subsequently is that the world and bad architecture has put a second elephant on there. And then everybody else in economics and politics is blaming all of us. So we're getting this situation where all of us are quite confused about what role we can play. So for me, it's quite important to start with a discussion like that. I believe that we need to reverse, and I'm not suggesting we go back 4,000 years, but we need to reverse all of this, and the thing that we can do it with is design and innovation. I balance in my life. What I do all of the time is that I have to find ways of navigating what I just told you. So I am an engineer. I have the mind of an engineer. I have the eyes of a human being, and I have the eyes of an architect as well. And I work around this. So the simplest way to describe this is, how do I distinguish between, say, novelty and innovation in architecture? I try and move the pivot. So we are the pivot that moves from one side where there's a lot of naive acceptance of the education of an architect and practicing architects, or from the construction world, there's a biased rejection of any clever idea we decide should be tried. So this happens in my daily life, and what I have to keep doing is move the model. So I move my pivot across this world, across these two worlds, to try and see. Sometimes I am responsible for making exotic buildings. Sometimes I'm responsible for making novel buildings, and I will show you some of them. But often I work with ruthless efficiency. I work with known models and gravity. But I don't make those decisions lightly. So you will see through the work that sometimes I move to the left, sometimes I move to the right. The reason is because I class myself as a design engineer. The difference being that engineering as a science is finite, and we're polarized in what we do. When you enter the field of design with good architects, and you actually have this, what I would call the boundary between the two, you can create a lot of innovation. Now, what has happened with that kind of innovation, sadly, is the first 10 years of my office, we're 24 years old, was innovation came in this shape. You know, we all saw these amazing examples of what used to be an Olympic stadium that we made 50 years ago, and then 20 years ago when the Olympics happened in Beijing, suddenly we make something that is 330 meters wide, and it is enormous compared to what we used to do as a society. So bigness has created a certain kind of ugliness. And then this ugliness has also been handled badly by all of us. In my case, I was excited by the notion of this geometry of a bird's nest. But when you look in detail, and when you go to China, you realize it could be a shoe. So what happened, I think, effectively, is that we learned to micro and macro at the click of a button and at a very quick talk. And this is not, in my opinion, innovation. And that kind of innovation, which you largely see in large-scale structures, particularly airports, you see an ugliness in it. And I think we need to re-engineer this or rethink. The reason that it's very relevant right now is because if you took the steel from that stadium and you made a belt out of it, it would wrap the earth at least 4 times. So it tells you that we got something wrong if we had to use 40% of the steel of the whole world that year to build that stadium. So that's one type of concern I have. And I was part of the game that made the bird's nest and this kind of sexy, amazing, cool buildings, let's say. And now I'm having to rewind and have a look at why it's not always the right answer. So one of the kind of logics of that is that we found ourselves in this world where we were learning to use the tool, and we were finding that there are 3 very simple stories in this. The top story is about the engineer who can produce almost anything. You can keep moving it. He can even dance with gravity. And the top technology allows us that. The second was that everybody talks, and I hear it here, digital fabrication. You know, we can do this, we can 3D print a house. And then the third, and the real problem that we've discovered in the last, particularly the last 10 years, is that there's no interoperability between these. The tools don't talk to each other, and there is real concern about how architects and engineers work. Engineers, architects work with construction people, and then all of us work backwards with universities in educating the future disciplines. So I think all of this is broken in many ways, and I have to admit, I was part of the problem at the beginning, because I used to do the same thing as what every other engineer and designer were doing. We bought all the software that there was in the world to make sure we can deal with anything for a profit. And we learned very quickly that this ship, after 10 years, was losing the compass. So it had no direction. We had lots of software, weapons-grade software. So I'm now rewinding on that, and I'm saying to myself, I think that we have to be cautious about technology. It isn't the answer to, and I come back to the positive side of AI, binary and without a soul, that's what it is. Technology, as a truth, it absolves moral responsibility. So you can do almost anything for some reason or for no purpose whatsoever, and that's through technology. It removes the need for any accountability and agency, particularly with engineers and scientists. We're not accountable if we use technology. So tools are not innocent in that way, and we need to be cautious that pervasive imagery, and I am also a fan of Instagram and a fan of social media and making buildings through image. But the pervasive nature of what it convinces you to do is often entirely misplaced in my view. So there's a much deeper role that we can play as designers. So I'm finishing this, then I'm going to go into the projects. When I started the practice, I thought there were 3 axes. There was the axis of value, the axis of complexity, and the axis of efficiency. These are the 3 things that all of us are expected to do for our city, for our clients, for our planners, for our constructors. And I found myself in that green cube with that balancing act I talked to you about, where I don't believe in any of it at the extreme. So not everything I do is complex. In fact, I simplify complex things. And then not everything I do is structurally efficient. And not everything I do has the value as it's measured today. And I heard it in Turkey as well. What is the square meterage? What is the volume of concrete? And so on. This is quantification. There is no value to some of these things. Today, the same diagram has got bigger. With the challenges of climate change, with the introduction of AI, I know that complexity is very simple now to solve, very, very quick. The whole issue of efficiency has changed in that we now have no doubt that planetary boundaries, which is some people call sustainability, is what is going to drive efficiency, not anybody else, not profits, not economics. And most importantly, the vertical axis of value, I want people to stop thinking about it as a statue, which is how it is when you quantify it. If you think of it more as a dance, you soon realize why you still have buildings from the 1600s and 4,000-year-old buildings that we all find so interesting and valuable. So value needs to change into some other way of measurement. The last two slides in the introduction, the first one is, who are the innovators? So there is the dolphin that's innovating. We'll come here and do a lecture for you, always. The problem with the dolphin is that they can only speak to each other. They understand each other, but you won't understand dolphin. So you have to learn to speak dolphin, or you have to question what they do. Then there is the Manta Ray, which is the fish that is trying to fly at the same time. He does nothing well. He can't fly very well, and he can't swim very well. So this is a type of innovator that I think is pretending in some ways to be innovating and creating design. The most dangerous one is the mutant between the two, which is the one that is genetically modified and parametrically modeled in order to create this complex being, which in some instances has done incredible work, but sometimes only. Quite often, it's damaging. And the worst situation is the octopus, in my opinion. This type of innovator has no strong hand. He has many hands, and he can touch many things, but he cannot make a difference to the world. So I'm going to talk now about the world of design and the design of the world at the same time. I'm going to talk about the design of a business and the business of design. Throughout my lecture, I'll show you what I mean. The biggest toolbox that I have for that, and this is the office's diagram, is we didn't think outside the box. We're still the structural engineer, but we have all these other disciplines in my office to be able to innovate what I'm going to show you. We made the box really big, so we're still inside the box. The days of thinking outside the box is old history. We're in this huge situation where we're redefining our discipline and trying to deal so much with many other disciplines, from ethnography to social sciences. Even as an engineer, I need to understand some of these things. So that's the introduction. I'm going to do it in 3 chapters, very carefully and very quickly. The interpreter who is doing simultaneous interpretation, I hope, can keep up with me. I promised her that I would at least mention the names of the project. It can't be easy for her, but I'll try. So I'm calling them vertical systems, and I reinforce that. Vertical systems, not vertical buildings, okay? There is no such thing as vertical architecture, just so you all know. I'm calling the 2nd chapter working with all the senses, and the 3rd chapter horizontal systems, and I don't mean horizontal buildings, okay? So I'm going to divide my work into these 3 and start showing you very quickly what I mean by this. So I could talk about all the towers of the world. I've got many of these projects that I can show you with Zaha Hadid, with Norman Foster, with so many architects who are builders and so on. But I chose that I will show you just one. And before I do that, this is not what I like. This is not what I believe in. This is indecent, I think, and this has been one of the causes or one of the reflections that I've had. By seeing these kind of things, I've been wondering why we as engineers didn't question some of this, because most of this is rude, it's indecent, and it is not good to have these sorts of things in your city. So the first project I want to show you was actually how do you innovate? How do you innovate a vertical system? So we were invited a while back by a very important, in our city, we have the Canary Wharf, which is a tall buildings district. We were invited by our client to do a competition where you can stack tins to create something special that's artistic. They had 8 people invited, and we won the competition by stacking tuna tins. And the idea is that these tuna tins then go to homeless people. So we came up with this idea of a very simple geometric twist, which was very interesting because we hadn't ever designed or built on that site in Canary Wharf. Our client didn't know us very well. But this thing impressed them in the way we were thinking and how innovative we were. So the first project that was born out of that was a competition for a master plan in that district, which is Herzog de Meuron as the architect. The project is called One Park Drive. It's just finishing on site. I'm just going to show you quickly how to innovate in what is largely an extrusion. So a district is like this. As you see, it's been built over 30 years into an office world, big office world on reclaimed land. The new district to the right had to turn the corner. We had to announce ourselves as a new district for residential and different types of buildings. So one of the big issues was identity and relationship to the history without destroying it. And we entered the competition with Herzog de Meuron, and I will show you the finished project. But the basic idea was to really introduce on this master plan. So the competition was for the master plan and for the first tower. So we proposed a circular building to announce and give the place a new identity. Now, everybody has seen a circular building, so there is nothing innovative about a cylinder. There are many of them around. But when you work at this level of competition, I just show you some of the slides of Herzog de Meuron during the competition. There is an instant reaction when we work together with this sort of architects. We use all the technologies, that very big toolbox, every part of that toolbox, in order to iterate and invent the reason why we want to do what we want to do. So instead of doing a circular building, a square building, we moved on to a circular building, which differentiates, from the commercial grid. It announces and gives us views, equal views around the full circle, so nobody is special. Everybody has a certain view. And then, in many respects, it allows us to bring the building closer to the water, which gives it more value. Anybody who designs residential will know that. But it also engages the building with a different type of geometry. Why do I expand on this? So it's not as simple as that. The building then goes from being a rectangular grid inside a cylinder to rotating it very simply. But the most innovative thing was really to change the typology in the vertical extrusion. So instead of putting the best apartments on the top, we have just one penthouse. You put them in the middle, you put them, distribute them, so you don't create the value that is currently thought of, which is the top 3 apartments are big for the very rich people, and they will pay for the rest of the building. That was done through a very detailed design where penthouses are up there and they can be converted. The middle cluster has winter gardens and some sky amenities. The cluster at the bottom is like what I would call the most expensive cluster, the fat one, and then the lofts at the bottom rather than right at the top. This is done through the technological ideas. I mean, this is the very simple diagram that shows you how we create gardens. But what's interesting is how technology is used. So the normal conversation is about this, where is the core and how big is the core, how many lifts. Last time we did a 100-meter building, it was 5 lifts. Why is it more, less? So this conversation stops the production of or installation of a tower. And you really have to wait, as a developer, you have to wait until you have finished before you can sell. So it's a big investment. Now the tools are allowing us to collaborate within the system. So what you see here is effectively not a singular way of stabilizing the building, but a combination of core, external facade, and other means of stabilizing the building. And you can only do that live, week by week, by running the kind of software that I'm showing you. So what happens in that situation is that, oops, go back a bit, beg your pardon. What you're seeing here is that we're calculating the area. We're calculating the area as well as moving the structural system, all of that at the same time as the quantification is being done in terms of net area. So we don't fix the size of the core. We don't necessarily choose to freeze the design until the last moment. And this is best seen like this. So if you see the way this works. And if you remember that competition that we did with tins, basically there's a spiral change, so the columns are moving all of the time. By doing this trick, we can change every room in every cluster is different. So even though it's an extrusion, this geometry and this collaboration between different softwares allows us to push the boundary of technology to a point where the innovation is really about how you live in vertical systems. Because the question is not about doing a tall building. The question is about introducing a way of living in London in vertical cities, because tradition doesn't allow that always. Most of the investors buy these things. So one way of doing that is to come up with a new architecture. So what you're seeing there is the speed with which we do it. At the same time, the macro-micro connection. So we're looking at the master plan and our building, what is the future of the wind loads, and so on and so on. So very quickly, I speed that up. Every piece of facade has to be drawn. And one of the most important things about the facade really is that the ratio of the wall to floor is like no other tower that we've ever done. Very high ratio of facade, very expensive piece. I'm sure most of the developers in Turkey will not build something like this for the next 40 years. It's too innovative. It is too clever, and it needs too much of the empirical system, because they come in, they will always say, and this is right across the world, we only want 5 lifts. The ratio of wall to floor only has to be 20% or whatever, and they will not allow this kind of innovation. This client understood that by wrapping a lot of facade, we could actually create a value. And then we could take that further into the materiality and try and tackle some of the ecological problems. So what you're looking at is how the facade design, which is an extruded terracotta, glazed extruded terracotta, which is a natural material, can also add to the ecological conversation and lifespan of a building like this. So complexity is dealt with by binding the micro and macro during design, but also by binding it during construction. So you're seeing now the finished object, almost finished. We've started selling quite a lot of these flats already. I have some movies of this, but I'm not going to take my time on this, too much time on this, I think. Well, actually, you can see some there. So you can see how, when you walk through the main district, it announces a new district. You can see how, I think at least, it is so different from everything that's around it. So people take an interest in the architecture, and you know which is your room when you buy it, even in a tower like this. The second tower, or the second vertical system, is the opposite, with Richard Rogers as the architect. It's called High Point in Elephant and Castle, and it's largely about affordable housing. So I wanted to show you a couple of vertical systems, because the assumption is they're the most difficult things we do. As engineers, it's much easier to do a small footprint, tall building, and in fact, ecologically, I can prove that that is better to do in most cities than to spread the buildings. So this was particularly to show to you the material change, affordable housing, but also how a different architect like Richard Rogers, who is kind of a modernist, might work on something very, very low cost. So I'm going to fly through this one, but I can tell you very quickly that it was a competition by the mayor. We won the competition. And here, again, some of the same tricks from one project to another. How can we change the stabilizing system instead of using the core everywhere? And then how do we turn, this time, a boring square into something interesting by just cutting the corners of the square, so you do still get natural light into the whole space, and you can use that corner for external garden space. So we're suspending from the top. This is 148 meters tall. We're suspending from the top some balconies that give the building an identity. It's quite cheap, quite quick, and these are the kind of same methodologies that we use to arrive at a solution like that. I wanted to not go into detail, but I can show you that the tricky thing was really the balconies, because for that height in temperature, they can sink. So we had to model very carefully the temperature changes and model very carefully the vibration, because people are very scared of moving. So now we have sensors installed inside this building it's finished, to measure and test back our work. So we're doing quite a lot of post-occupancy analysis to see if the tools work. I fly through it. One half of the building is largely low-cost rentable property, and that is 9 floors high, which we have done, which was the first quite large-scale mid-rise CLT timber, mass timber building to be built by Richard Rogers especially. So we finished this. It's in the center of London right now and sold most of it. So I fly through this. I go into the second chapter, which is working with all the senses. And this is a mixture of vertical, horizontal systems. And I start first with the vessel in New York, which is the collaboration between architect, artist, engineer. So the competition was for a public space in Hudson Yard, New York. And we entered it with Thomas Heatherwick. So this is the vessel with Thomas Heatherwick. And the idea that we came up with was really to create an object, a small footprint so people can gather around it at the ground level, but then get people up to the top at about 70 meters, because most of the buildings around are very tall, and you can see New York from the height, and you can see it from the ground. But about 70 meters, we couldn't find anything that was relevant in our eyes, so we did a mapping of the city to see what looks different for the public, because this is public access. So we invented this idea of a conical system, and it was inspired partly by old engineering. So between New Jersey and Hudson Yard, there is a tunnel that was built in the late 1800s by engineers that hangs. It's the first catenary and the last catenary tunnel ever built. So we were inspired by the fact that when it arrives, you can see where the vessel is, was where the old vent used to be for heat. So it would dissipate like the shape of the cone. But the second inspiration was the stepped wells of India, where you could use that technique, where there it was for water reservoirs, but we were looking at health here. So we thought we could take this shape and kind of unfold it, make a very simple atomization of it. So the atom in that system is the shape of a dog bone, and then stack this as a brick as you go up the building. And the clever or most difficult thing about it is that it struggles with, again, the most technically challenging bit, because it's inverted cone, is to let it not vibrate. So you can imagine the effort we would have to go through to take the dynamic analysis of something that doesn't want to be that shape. It wants to be the reverse. So what happens in that scenario, these are staircases that fly, basically. Okay, bear with me 1 second. The section, as you take it up, basically gets bigger, and you get this wrap of a geometry that is self-assembled. What's quite interesting about it is that most of it, all of it was designed in London by us. We had an engineer of record, which was, I'm talking about the business of design now. We have to do this sometimes. We're in foreign countries because we have to make it so complicated that the local engineers can't do it. Because every time we do clever things, they steal and they kick us out after they got our idea. This is all over the world. It's not only in the East. It happens in the most developed parts of the world. So we create complexity to a point where only we can really engineer it. And in this particular case, the tolerances, which were 1 millimeter tolerances in assembly, meant that nobody in the north of America could make it. It was all made in Italy by Ciumalai, a very good steel fabricator, because the technology of steel is still better in some parts in Europe than it is in the north, or at least in North America. So a lot of things were learned through this, but the most important thing was how to model these people. How do we model for 3,000 people at the same time, or one person at the same time? And then how do we resolve that problem when the American football team will go in the top right-hand corner and shake it? And I can tell you that we had to take technology from the previous vertical systems and put some tune mass dampers inside this system, which nobody knows. You won't see them if you go there. But basically that allows us for all weights, all sizes, all shapes, all different symmetries, so that you can put 200 people in one corner and it's not going to vibrate. at least not in my lifetime. So we should be okay with that, I think. I wanted to continue with this all senses. So that was about sensing public space, sensing the idea of what happens to you in your body when you climb, and how does engineer actually invent some systems that do that. Pop-up cities like the Olympics are a great time to invent and be innovative. So we took the opportunity during the 2012 Olympics to do many projects. We were very lucky. We won about 12 competitions. And I only want to show you one. And they're not all sexy or cool. Like the power station, you might think, you know, architecture, no design. But I can tell you that that was the most profitable project ever that we did. So you sometimes have to think of the fee, because the machines are so expensive inside that building. The role of the architect and engineer is negligible. So you can actually make a lot of advantage and get paid properly for your value system in a way. We also did the school and bridges and a lot of the pavilions. I want to show you this one, the Coca-Cola one, because it is the probably iconic project that left the thread of all senses behind. The final product looks like this, which is quite chaotic or at least crazy looking. The main challenge was really to convince Coca-Cola not to write Coca-Cola on their pavilion, but really to refer to it as an experience. And we came up with the idea of a very simple spiral, 400 meters long in structural terms, that you could walk in exactly 12 minutes. You get to the top, and you get either a bronze, gold, or silver Coca-Cola on top. So everybody would be kind of experiencing some of the Olympics, some of Coca-Cola. They can sell more of that if they want. And then we, as engineers, would have to solve this problem. How do you create the image? So the image is really, the architect in this was Hanif Kara, by the way. The image is really about a very simple reciprocal system. So we have a simple spiral and then a reciprocal cushion that is as a triple pillow that moves around. So geometrically, if those who have studied certainly all of Islamic architecture, you'll know that there's some repetition in these kind of periodic geometries. So whilst it looks complex as a whole, the simple tile within it is actually scripted in a very simple algorithm. So the foil cushions basically can be arranged in this way. But the most interesting thing was, what do they do? As you go up the spiral, we collaborated with a rap star, a rap musician, and some very important Japanese acoustic engineers during the competition. And what we proposed was that we would have this. Okay, my slide's not working, but we will keep going. At that moment, this guy hits the pillow. It was working earlier, by the way. And it makes a sound. So what was happening is, this is a musical instrument. As you go up the spiral, you are able to experience the sounds of the Olympics. You can bang on this. So it's playing with your other senses as well at the same time. So there's a design where you have transdisciplinary, interdisciplinary collaborations between artist, musician, architect, and engineer, and client, to create a whole new experience. And I can assure you, for anybody who managed to get in it, it was really cool.
So it's a table tennis action.
This was the prototype we made, because when we were shortlisted to the last 3, nobody believed this was possible. So we made this prototype and we took it to the competition and we showed them how it actually works. So we had all these successful technologies that allowed us to do that. Now the wonderful thing that comes out of this kind of thinking is that also it is so clever that other people want some of it. You know, I want one of those, is what the Russians said in Sochi. So when Sochi Olympics happened the following year, they came to the same team and they said, we want you to do something with all the senses. I don't think they knew what they meant. We thought, okay, we can't repeat Coca-Cola. So the thing we will try to repeat is the current culture of Instagram, where we know that the sweetest view that every one of us has is in the morning when we look at our own face in the mirror. That is the most beautiful view that you ever see in your life. And when somebody calls your name, that is one of the sweetest sounds to you. So how can we tap that during an event like the Olympics? So again, with Hanif Kara, a very boring structure. What we proposed really was to create an Instagram where you would go through this pavilion very quickly. Within 2 minutes, you come out, and it would print your face on the outside. So you could stand outside and look at yourself after you walk through at this very gigantic scale. The concept is very simple. You take people, you connect them with technology, you make them into the new hero, so they can feel a hero for about 20 seconds whilst the next person is going in. And this is playing with all of the senses of design technologically, and also the opportunity to experiment. So I can show you the first time ever that this worked. The architect is there on site, and we didn't know, because you can't prototype this, we didn't know whether this would work. But why I know it was very successful is you see him just now in this video for the first time. So these are the clips that were taken during the process that we were making it horizontally. But when we moved it up into the first ever, which was late at night, this is the architect. I have never seen an architect cry. He cried that night because he could see his face in that wall. So not only are we doing this for you, but we were doing it for him and me as well, to try and say technology has some benefits, some value, and if you tap into the other senses sometimes, you can go beyond architecture and beyond engineering. Now, the most innovative, or one of the most innovative projects I want to show, where it's major innovation, not minor innovation. I deliberately chose the Serpentine Pavilion. I could show many of our projects, but I think it's better to show this one because you understand kind of the logic. This is with Bjarke Ingels, and the technology is such that between the two offices we work a lot together. When we're invited, it's always a competition. You have to win within a week. There are 5 people competing. You build it in 8 weeks. So remember the pace at which you have to do this every year, okay? We were invited with 5 others. They were all working on one idea. We managed to produce 8 at the same time. So they were all out. Because if you come to your client and all of you produce 1 and I can show 8 ideas, you know who he's going to speak to next. That's what literally happens. Within the next meeting, we were able to get rid of 2 typologies, the one on the right and the one on the left. By the way, we didn't invent all of this for the competitions. These are in our drawer. You know, we've been doing these works with this architect for 15 years, 20 years since they started. So we all have old projects that we can bring out. And we built, in the end, what I call the single sinus wall. And the very simple story was, the English think the brick is English. So if a Danish guy wants to do a brick, let's do it differently. Let's show them what a new brick looks like. And then let's also redefine the purpose of a wall. Let's move it and make this sine curve, double sine curve, that actually becomes the space, which is not new. Daist, the Uruguayan engineer architect, many years ago did these kind of tricks. But the third component was, let's do it with a new material. So the size of it and the speed with which we have to build it is with a PFRC, so it's glass reinforced plastic, from Copenhagen, because he doesn't want this to be built in Britain, because he thinks that he needs to support his market back home, but also because he thinks that this material is better, but also he thinks that in terms of collaboration, the locals will respect him more than the British will. So in a way, there's a designing process going on that is not just about strategy, it's about a design process. And then the speed is necessary because our office is in London, they're in New York and Copenhagen, so it is an hourly rotation of material, an hourly discussion, which can only happen through new processes. So there's a completely non-linear process going on in the background where we are doing the geometry, we're then looking at the same time as the global shape, FEA models of the global, local models, structured database, because we have to give this to somebody to make, and all contractors claim they can make it. They can't always. The engineers often make things better than contractors. I believe that very strongly because I've seen it. They all promise to do things that they can't sometimes. So we had to make sure that they can this time and succeed, so it's also good for their business. I show you quickly some of the under the hood material. So what you're seeing here is the form taking shape. This is what happens to the shape. Every single brick does a different job. It has a different strength, It has to be different thickness if you're going to make it out of this very expensive glass fiber. And it has to be made out of an extrusion. So it is not a brick. We have to make the brick because it's about 300 by 300 and just long enough to make a coffin later for recycling. So we can actually reuse this potentially. And you can see some of the tools are doing micro analysis. So this is the finite element analysis that's going on of each of the boxes and how it is behaving. Where can we take thickness out and thinness out? At the same time, in Copenhagen, they're making it because it's not tested, this material. So we were making it while we were doing the analysis. This is a collapsed process. And then you see the kind of diagram of what is happening in parallel. You have the drawing work going on, the analysis and the making, all at the same time. And then loops that go through that. So that big box, again, that I showed you, the processes that we go through to arrive at some of these solutions take a lot of risks, but quite often they are engineered, and we're working computationally. So I'm not against artificial intelligence or scripting, but how you use that kind of technology in order to invent is the thing that I'm trying to describe. What you're seeing here is the mapping of the deflection. So all of these pieces have also got to be safe in use through wind. And then we have to build a database so that we can send a little disk and the contractor can look at the disk and just keep making it. So everything is automated very, very quickly. So I think this is kind of beginning to demonstrate the role of computation, the extreme abilities of computational tools in the right hand. Like I said, if you give it to the wrong people, it becomes a weapon. The fortunate thing here was that both BIG and us have worked well together in the past and grown up together. We understand the limitations of this, and Bjarke is a better storyteller than anybody else in the world. So in a way, he can actually tell the story, and we can do the technology behind it. And here you see how we installed it very, very quickly. And finally, the objective, which was to make it transparent from one direction. So I was hoping to this to play, but it didn't. Give me 1 second. I don't know why it's doing that. It's supposed to play now. Okay, I move on. But there was a movie of it, basically a drone movie that we took, and it was on YouTube. You probably can see it on YouTube. So I'm still with all the senses, and I come back to ugliness. We have been involved in one of the most important developments in London for 20 years, which is the King's Cross development. And the pink shroud is the new Google headquarters, which we're doing with Bjarke Ingels and Thomas Heatherwick. But we've done all of those yellow buildings on that site over 20 years. Now, on the one hand, it is very successful as a master plan. On the other hand, it has chosen, like David Chipperfield, Eric Parry, Stanton Williams, Thomas Heatherwick. They're all of the really good architects, in theory, to do this big master plan. Why I say that this is a new kind of ugliness is the homogenization. So what we're seeing is that none of these architects has done his best building on this site, because you are putting in place a slow burn city with too many rules, and they're not really allowed to innovate. They can't do anything special. And they all did kind of something. And at the moment, I mean, as real estate, it's great, and as a public space, it's great. But my own opinion is it's a homogenization of an idea. So it creates this homogeneous architecture where none of the architects get to do their best design. And this is something that I think all cities are suffering from at the scale of master plan. So slow burn cities are not like pop-up cities in the Olympics. You don't get as much chance to innovate. But we're lucky. We're very lucky. So we got a chance to compete for the headquarters for Google, and I'm going to show the Mountain View one. But this is the London headquarters with Heatherwick and Bjarke Ingels as the architect. It is 400 meters long, so if you stand it up, it's taller than the Shard. I'm not going to go into the detail because I'll talk about the other Google. Now I want to connect back to education. So I've been introduced, and I've been teaching at Harvard for 12 years as a designer, not as an architect or as an engineer. And what do I do there? How do I connect this back? So we chose last year to question homogenization in London by having the studio, 14 students in my office, doing a full semester where they looked at a site in London where the next King's Cross is already in the making. And they looked at, we gave them a site, and 14 of them were to divide this up without any rules, and they were supposed to create what we would call the universal building. If there is such a thing as something universal in workspace, what is it, and how can you make it in London so we do not make another homogeneous idea? So this was a 14-week piece of research, and one of the interesting sides to it was that in collaboration with the design, we also created an axis of the architects, the non-architects, the integrated people, and the specialized people in London who are the mafia in terms of what we build. So we found all these people who influence everything we're doing, and we invited them once a week to come and do a 3-hour seminar so we could learn live with our students, because people will talk in front of students about things they would not say in professional meetings. You can learn so much in 3 hours about how good they are, how bad they are, and how many lies they tell. So it was very interesting to actually get all these disciplines that deal with architecture and the built environment through it. So this was the very simple idea, and the conceptual idea of a universal building was referring back to the exquisite corpse, because cities are usually corpse of one generation and another generation stacked on layers and layers. The scientific version of that was that we gave them the task that it must last 100 years, because that's ecologically good. And engineers and scientists can make you like this. If you do all these things to your body, you will live 100 years. But you will be very ugly, and nobody will want kids with you. So you have to be very, very careful about what it is you're creating, the monsters that we can create, why you're creating this. And this was kind of a parallel conversation. The architect Simon Oldford was co-teaching, so I never teach architecture on my own. When I'm doing a studio, it's always in collaboration with an architect. So this particular architect is interested in workspace. And one of the other constraints we set them was they had to take all their work back to Boston, like the old days, in a little box and present it to a jury rather than just CGIs and computational diagrams. They had those as well. And this was the final result, where you see that after 12 weeks, we allowed them to talk to each other. This is what happens in a city. Nobody allows you to talk to your neighbor or the planner. At the last minute, they allow you to do it. And we managed to get some solutions out of them. But the most important thing we learned from them is they had studied 14 master plans in London, and they found that 90% of the words that describe those master plans were photocopies. So 90% of what we're going to build over the next 30 years in London is done by one hand, writing the same thing, same over and over. No room for innovation. This is why I talk about minor innovation in part. So connecting education back to practice is important. The most important project in this group, and I'll move to the last chapter in a minute, please bear with me, is the Bloomberg Headquarters, which is officially the greenest workspace in the world. Officially, you can check this. And if you don't understand what green means, go and look at this project and ask Foster and Partners what it actually means. The challenge was to build right in the heart of the city, the last island in the city of London. The context was St. Paul's, so it's like building literally next to Hagia Sophia, although here there is some freedom to do some rubbish next to your treasures, where in London there's a lot of political issues that you cannot do this stuff, especially when the site is so expensive. So our client was Mayor Bloomberg, and the architect that we won the competition with was Norman Foster, and it took 7 years, 8 years from design to construction. I say it's an interesting building. I think it won the Sterling Prize last year, first office building to win a Sterling Prize. And I say it because of all the things we learned from it. So there are systems in there that are important, and I'm not going to go through all of them. But kind of the themes of what is happening in this kind of building, from Londonness, which is to do with how do you reconnect to the earth, literally in that case, history of London, the knowledge that we have built, technological knowledge from the vessel and all these projects, and then the issues of infrastructure, which are the biggest problems that all cities are now facing. When we arrived on site, we found a lot of tunnels, sewers, buildings, all sorts of things underneath it. So we came up with this master plan very quickly, which is 2 buildings with a street reconnecting one end of the town to the other. And then we designed the buildings. This is the finished object. And you see that the important thing about the building is that the way people work in this building is they have to go to the top, celebrate arriving to Bloomberg, eat some croissants, and then walk down to their desks. So one of the interesting things is, how do you create productivity in a building? How do you make people happier? By making them well, making them healthier, and so on. So there is a lot of detail in it, and we used all sorts of technologies, from minor computational analysis to water baths, which measure air quality. And the reason for this is because for the next 20 years, the air quality in London is not good enough to breathe through the building. So what we've designed in, and this is why it's one of the innovations, is through the facade, over time, what's going to happen is that this facade is designed to allow us to, like a fish's ear, to allow us to breathe, let the building take a breathing envelope system inside. So this is the detail of the facade, very large stone. This is 2 floors to make the building look smaller, and then a bronze fin that will in time be allowed to breathe. So there's a lot of invention and innovation in the system. This was not done by the facade contractor. It was done with the design team, Foster & Partners, us, and the mechanical engineer. So we wanted to push the boundaries of this material and try and show the technology. So I can show you a lot of detail on this, but I want to skip some of the detail. You know, while you're working at the micro level in this, the big problem on the building was really nothing to do with that. The shape and everything of the building was driven by the fact that we discovered Londanium underneath, which was the center of Roman London. So what had happened since the 1910 developments was 3 generations of engineers had built, piled through a lot of our Roman city. When we exposed it, it was very interesting because Mayor Bloomberg, for his legacy, and Norman Foster, for his legacy, wanted to use this again. So recreate a museum inside the building, but equally we took extra 18 months so that all of these things were mapped. Now they're in the Museum of London. We found something like, I think, 800 iPads in stone. So the original iPad, which is a tablet by the Romans, we found them underneath there, and we found a lot of other very, very important archaeological finds. So this and the shape of the building was really, this is the museum now, if you're ever in London, but this was what made the building. The gray is what engineers had put in the ground over 40 years. So in theory, with the wrong engineer, you can't build on this. And if the engineer is not as strong as he needs to be, the architect will build something that cannot stand up. So what we had to do is actually form fine together what is the shape of 1 million square feet going to be based on only the red piles, and use the gray piles as a structure-soil interaction. So we developed a piece of software that would allow us not to ignore them, use them for energy dissipation, but also to use them to strengthen the soil, because that's something we can rely on. So the innovation was really invisible. It's below the ground. Everybody enjoys the building. And this came again through some of the technologies that you saw. So I see steel work there. I don't want to brag about steel, but this, if you opened it up and made it into the shard would be 1/3 longer. So it is the biggest steel building in London at the moment. Again, the idea from Asif Khan's pavilion, where we have a reciprocal system to create an entrance where there are no columns, and the entrance is sucking you up like a kind of volute to suck the geometry, invites you. Olafsson did a piece of art in there, a number of very important artists. So we built this self-standing spiral, which is art, architecture material, because it's very similar material to the Heatherwick piece in steel covered with bronze. And what I show you in the middle is probably the biggest innovation, because to do this kind of construction on site, you have to put the ghost on site. It's the only way. We had a model on site X-ray model that we could use with laser beams to make sure that every millimeter was captured as we start building, because you cannot make a mistake when you're doing things like this. Here you see the pantry at the top, where you can see the St. Paul's view, very interesting view, and then you see some of the outcomes. On the outside of the building, the public space is also utilized, because one of the most important things in London is terrorism, and we have to be very careful about how much terrorism we can allow to get to our building. We've designed it for a certain amount, but what you see is the forgotten rivers brought up into a piece of art in the surface. So these new techniques are used to allow us to do this. So I go across to Bjarke Ingels and the twist very quickly, because all of these projects connect. The horizontal systems, the kind of other sense. When an architect wants to do a museum and an engineer wants to do a bridge, what you should do is tell your client he needs a bridge that's also a museum. Then you can both get something out of it. So when we were invited to do this, the brief was to do a sculpture in a park. And we created this wonderful thing, which those of you who follow the internet will know was a massive hit when we opened it. It's called The Twist. It's a museum that is also sculpture, art, and space, but also in a very picturesque conceptual idea that does some work for us. And the structural idea is not that complicated, but it plays with this geometry of forcing the form to twist and then move around. Some of the kind of analysis methods that I showed you earlier. So I show you the construction, and for me, this image perhaps shows how innovative an innovation can create another kind of beauty, because some of the images of this are already turning into paintings. It took the Eiffel Tower nearly 100 years to be accepted. Today's media and social media, it took us a week to make this one of the most famous projects in the world. And there are already paintings, very expensive paintings that people have done of this. I'm waiting for the first poetry, but I'm sure it will come. So it's connected also to education again. With Harvard students, I chose to do extreme environments. I'm coming to the end. And I do a studio sometimes. This was with Spela Vidnik, who is from Office Architects in Ljubljana, a very young architect, who was my former student a long time ago. We put them to a task. We said, make something that will save lives on top of a stone, a rock, a big mountain. And we chose one of them. And the idea was to build this thing fast with drones. And we were lucky enough to choose a student and find a solution that would work. The unfortunate thing is the sponsor dried up. The drone sponsor disappeared because they got scared of the system at some point. So we managed to get the army to lend us a helicopter for 2 hours, which was a lot of work by Office to persuade their country and the government that this was going to hit big time in terms of the technologies that we can use to save lives. So building in extreme environments from a pedagogical point of view, taking it into practice, is what this project was about. I'm still ambitious to see if we can find drones that will lift something like this and create something as beautiful as this. So this has been quite a successful, small, what might be a student project, but it's shown us different ways of thinking of things. Last, I promise this is the last chapter, horizontal systems. Do you want me to stop? I can, by the way. No? Okay, horizontal systems. So this is Birmingham New Street Station in London, just outside London. Second busiest station in the UK. There was an international competition. Existing building looked like this, and they wanted to renovate it because we had a lot of homeless people, bad security, drugs and crime around the station, and a lot of darkness around the properties. So the network rail people, and you see the railway lines underneath, they connect the north and south, a very busy station. Built in the 60s, and it's showing that you put an air rights building on top of a railway line, which is quite innovative in the 60s. But then what do you do with it when it runs out of its life? Because the trains continue. So we ran the competition, and we worked with, in this case, Foreign Office Architects against, I shouldn't name them all, but UN Studio, David Chipperfield, a number of people. We won the competition to design something very clever, which was really to bring light into the city and bring light into the space. So we cut a hole at the top, and we created a facade, which is the mirror on the outside. It is not a Frank Gehry wrap the paper facade. It's a very clever idea that brings light in. So what you see is that the model that you see here is what we presented at the competition stage by saying to the clients, look, this is what we want to do, and we think that the potential of making something that will reflect light by using a very simple idea where you take the skin and put a mirror, and you can just twist it very little bit, and you can avoid the light going into the eyes of a pilot or buildings next door, or shine the light. So by making a very simple geometric move, you can create this fantastic piece of work. And this is the tool. So we did an algorithm in the office which was looking at every minute of every year of the sun before climate change, every minute, and where the light would fall, literally, because the reflection of that mirror has to be very cleverly thought. So you can actually innovate by looking back at old systems, adding the weight or taking the weight off, or adding a new way of thinking about the space. Instead of being a dark, closed box, it's become a light box. And you need some knowledge of materials. Again, you don't rely always on the contractor. And we knew how much steel bends, how much stainless steel will bend, and how you can prototype this very quickly. Here you see the bare bones of the system, and then you see the finished construction. And you see one of the most important elevations suddenly is the trains are moving. And in the city, if you stand there, you can see the trains moving. It's like a piece of moving art. So there's a kinetic system that is now architectural that comes as a result of this simple idea. And it announces the entrance very easily. Everybody knows now how to get there. Gives the whole station a new idea. And the roof light is a very simple structural move. We knew that the concrete was redundant. We knew by doing analysis on it, we could put some weight back in, we could take some out. And we developed these leaning arches that support against each other and introduced foil on top, ETFE foil, and now it looks like this. In its first year, it had 1.2 million visitors, just so you know. These were not people taking the train. These were people just going to see the station. So you can imagine that the retail space now is extremely successful. And it's been one of the success stories of infrastructure projects. I want to show you a second type, and I have two more projects, I think, with David Chipperfield. So people always ask, you know, which one, today the media were asking, who's your favorite architect? Which architect is difficult to work with? And I already said, I don't make those choices. I respond to their position, and I will respond to what they're trying to create. In the case of the Turner Contemporary, which is now very famous, because last week we had the Turner Prize in there, the concept was we only had one site, and the city were giving us a regeneration site on the beach. And the beach floods by 2 to 3 meters at least 10 times every year before climate change. So one of the problems is that if we build on this site, we have to deal with one of the biggest problems of climate change is flooding. And it was an innovative idea. With David, it's usually about what boxes, how do you connect simple boxes? And it is harder than working with Zaha Hadid. Because with Zaha Hadid's work, we always find there is only one way to make it stand up. With David, he doesn't care about the structure. He knows what the structure will be. It is a box. So the conversation is really about light, the painting, how do you do a museum, how do you do the Turner mood, how can you create the exact light at a particular time of the year from where he did his paintings. And you can see that we did 36 ways of connecting boxes. So the research is a lot more complicated, even though it's a box, literally. Now, that doesn't mean that we didn't have to do the technology, and not all technology has the answer in computation. So when it comes to flooding, we have to make physical models, and we were still guessing to some point. So we did a flood analysis and tried to predict what will happen over the next 60 years, and this one of the most expensive museums in terms of what's inside it. So the paintings are really expensive, and nobody would insure it unless you're able to prove scientifically that it's very successful. So I fly through it. I show you some views of it, because I want to get to the end. And you see it open in great, marvelous, it's regenerated the whole city. I want to show one Zaha project, and not one of the famous ones. This is Michigan State University Broad Art Museum. and American strategy. So when we entered this competition for the new broad art, the first thing that Zaha said was they cannot do curves over there. And Detroit is nearby, so we have to think of the car. Ford did something important, so let's do straight lines. And the whole idea really was born out of folding. How can you make a folded system that will be everything? Forget the curves for a minute, forget her idea of 0 to 360 degrees, but how can we use the fold as a device that would allow us to make a museum? An art gallery. So when you fold it and then you actually excavate some of the folds and you insulate it, you can go from left to right. It can become structural, environmental, bring light in. You would think this is easy with Detroit car industry having nothing to do. You would think that they would be welcoming this. But they struggled for a long time. So we were nearly fired for 2 years. After 2 years of trying to push, even though we did a straight building, they tried to get rid of us. And then we have to retreat. So sometimes you have to make a decision. Is it better to retreat, lose your ideals, and make the innovation happen? So we chose to go with them and work with the systems. So the systems over there are sticks, plywood, which is Victorian in the UK, and then a skin that is now plated to it. So we didn't manage to achieve our real ambition, which was to create a folded system that could do all of these things, which ecologically in the future will be something important to think of. So not everything that we do is like it's written in a magazine. Part of the reason for doing this building was where it was, but also part who the client was, because we had to impress this client. And in part, it was because we had to prove that we can build in the US as a team, because she hadn't built anything, just one other project until that point over there. So I've done a lot of projects which I did, and I could talk a whole lecture about them, but I chose not to deliberately because I feel that you needed to hear like the broad range of work. And the last project is the Google headquarters with Heatherwick in Mountain View, California, which is a simple idea. The weather is different. So how can we create a new sky? Many people refer to Buckminster Fuller. I can tell you he wasn't that clever, really. He was a good speaker and good writer and good thinker, but he was not really clever as an engineer, because if you build anything he made, the surface area of these things is hugely, hugely horrible. You cannot actually afford to make some of these things. So we started with this image, but we actually reversed it by creating a sky that is now a very shallow dome, and you see this here. But the fundamental idea was about not building anything. So it's an ephemeral idea where you take the master plan, look at the human scale, and you build buildings inside that you can move over weekends, and you can move them in a month. So the sky on top becomes very important. The public space, which is the ground, the habitat, the connection with nature. But the bit in between, which is the human scale, daily use, changes all the time. And we managed to do that through, again, the similar sort of process as the Serpentine, where we go through a whole process of testing, analyzing, finding new ways of thinking of earthquakes, and so on and so on. So these innovations, in my opinion, are not major. They are asking new questions. So in this case, we were trying to take the air out of Buckminster Fuller's bubble in some ways by showing that today's technology can allow some of his dreams to come true, provided we were the engineer. And he didn't do the engineering. So in some ways, you get an opportunity to challenge these people. And you, in this case, one of the most important things was to model the rain, because when it's anticlastic, ponds grow. So one piece of software we developed in the office is how much of the water weight would we have to design. And then we invented a crab boat, which is the connection between a KUKA robot and a crane. And this can allow us to change the floors very quickly. This hit the internet 4 or 5 years ago. Google thought we were serious. It's just a kind of playful thing to do, but we will find a better way of doing it than this. But at the time, it was very successful. So I show you the construction, which is actually now finished. This was taken about 4 months ago. We've actually clad the whole thing now, and the first of the domes is finished. I connect this again to Harvard because this kind of large-scale thinking also involves design research. So I did 3 years of work at Harvard to enter the American market on infrastructure and large projects based on the idea that they do 90% landfill. Sweden does less than 5%. So I compared the two countries, and I wrote with my colleagues, there were researchers working with me for 3 years, the value of infrastructure and bringing architects into infrastructure projects and design into infrastructure. So this bar conversation, late night dinner conversation, we entered this competition together, won it, and we have then built it. So these dreams of trying to bring architects into creating new value are not pipe dreams. I've been very lucky in working with some of these people. And the book that we published on waste has also been really well received now. And I see a lot of people. So, last slide, my people. I don't do all this work by myself. We're very lucky in London. It is still European, at least till Thursday. And we have an average age of about 27 or 28, 350 people, mostly structural engineers, but we have others, envelope material scientists. And what's interesting is when you look at the identity of the office, it's not an individual. It's this thing that is about 27, is pale, is not dark or light, no plastic surgery. This is how he looks, or she, so it could be male or female. And this is pluralism in my world, in the sense that if you do not have this overlap, and I think Istanbul is one of the most pluralistic communities historically, and I think this is the richness of the office that we've managed to create. In my final world, so looking to the future, because I always get asked, you talk about these wonderful things, they're all sculptural. Do you do any affordable housing? Of course I do all this stuff. But where am I heading in the future? I see the future, the three fingers of creating, synthesizing, and being a discipline are fixed in that we are all good at that. If you're not, you should leave now and become a dancer or a Hollywood movie star or something. Because if you do not believe in your discipline, architecture or engineering, don't have passion for it, you cannot synthesize or create. Where I think we're all struggling is respect and the ethics. So as ethically, the responsibility we have to take for the worker and the citizen, this is not just about ecology. And then respectfully awareness of the other human being and his problems and his conditions. So these two elements, which you can't measure with square meters or volume of concrete, are part of my world of design. And I think in an increasingly denaturalized condition, which is what we're heading, with an ecology that abandons nature, largely, and occupies fields that are unnatural, which we have to do with AI in order to survive, we have to have this sort of behavior. And I don't believe that it is a problem. I think this is a fantastic new opportunity. Thank you. I will just say that I have a 2-hour version. I have many more projects that just in case you want to do a long night, okay? But I'll stop there. Thank you.
Thank you very much for this inspiring speech. I think we can take you there for the rest of the...
Take one picture of the audience?
Of course.
I'm not very good at this. But yeah, actually, can you take one for me?
Yeah, of course.
Just with the audience before we sit down.
Okay.
The young people especially.
Yeah, okay. Çekiyorum.
Thank you all again for showing us.
Profesör Hanif Kara'ya çok teşekkür ediyoruz konuşması için. Şimdi kendisine eşlik etmesi için Sayın Emre Aralık'ı sahneye almak istiyorum. Kendisine de davetimizi kabul ettiği için çok teşekkür ediyoruz. Hoş geldiniz.
Switch it on? Yeah. Before he starts, I just want to thank Suha Özkan, who's sitting in the front here, who you may not know, but I should tell you that everything you heard he had 1/12 in the making of that, because he made me famous by inviting me to the Aga Khan Award for Architecture, maybe 15, 20 years ago. And he is an amazing intellectual. Thank you for coming.
Hi.
My friend.
Yes. Hanif, you are so famous. I mean, like a world star. But it's true. And I know you personally since more than 10 years now. I think it was 2009. You were like one of the reviewers of Aga Khan Architectural Award.
Yes.
And you came to Turkey to see one of our buildings, to make a research about that and to prepare a report. And you went to Edirne. You were like a bit in the mood of British Secret Service.
Yes.
And you didn't want me to come with you.
Yes.
You stayed there for maybe 3 or 4 days by yourself, investigating everybody, including the workers and everybody around. And then you wanted me to come there, to go there, and then we passed something like 2 days. And I saw the report afterwards, after maybe 2 months or 3 months after this visit, and it was an architectural report rather than an engineering report.
Right.
So, but we all know that this is an architectural award as well.
Yes.
And now we are working together in the steering committee of Aga Khan Awards as well. And on the other hand, when I Googled your name yesterday to make some kind of a research, I saw at the first rank Hanif Kara, architect. And it's quite interesting, or even, in my opinion, a bit meaningful as well.
Right.
Because, as well as I know, you did not go to an architectural school,
No,
but you're teaching at Harvard Harvard GSD since more than 10 years now.
Yeah, yeah.
12 years maybe. And moreover, I recently watched an interview of you. There you were saying that you started to get inspiration from entering the gaps which you considered to be linguistic,
Yeah.
Technology, and aesthetics.
Yes.
And
You've done your homework.
yeah, a bit. And added these, let's say, other dimensions to the scientific discipline of structural engineering.
Yeah.
And it was maybe in order to create a new and unique practice. And I think you did it. You did it in a good way. You were talking, for example, you were talking about the library, the Peckham Library, saying that, you were mentioning about the beauty of the object, weirdly, in my opinion, as a building, and lifting it or in order to create a public space or public square.
Yeah.
I didn't hear any engineer talking like this. And you were mentioning about creating an attractive space as well. And you were talking about the playfulness of the interior as well. Then you were touching very shortly to on the spiky columns, but this time once again for saying that they act also for a wonderful skateboard area. So you're asserting that you definitely dealt with, let's say, more than scientific aspect of structural engineering. So it's really interesting and it's really touchy, in my opinion. Now, I have some questions on my mind. Firstly, what do you mean by saying that you dealt with more than the scientific aspects of structural engineering? And what kind of structural engineer are you? And do you have your eye on architecture? Because you're doing everything for this.
Yes. No. I mean, it is really good compliment that you have read this, and I was asked this question by the V&A, because It was an art exhibition about over Arab, and they were going around checking which engineers have done what. And I was difficult to place, except that I wear orange glasses, and I'm better looking than most of the others. So in a way, apart from that, they couldn't understand the difference. So I would agree with you that I repeat often that I'm entering linguistics, ethnography, all those areas of architecture, because I learned very early that as a scientist and technologist, you can do, if you become really good at it, which there are many engineers, you can actually then question the other spheres of thinking. And if the other spheres of thinking are good at their work, they're happy to hear your question. And they will, like you know, when we talk, when we work, it's a combination of talk. And I think this is what I mean by I go beyond the science. And I've learned in the 25 years that the origin of that, I think, is that I'm still old-fashioned, and I believe in that architecture is about making life better. And this partly comes from the Arcana word.
It's old-fashioned?
I think it's old-fashioned, yeah, because I think
architecture in that sense.
Yeah, I think it's old-fashioned because if you
what is
talk,
new fashion of architecture?
Well, the new fashion is about profit, profit. You know, and the new fashion is about shape, about color, about who's got the tallest one, who's got the longest one. These things, you know, I think, and they are forgetting that we are leaving behind something important after agriculture. I always say that we're leaving something behind. So both of us have a responsibility, and you need to recover your ground, because if you don't, as I showed in my first slide, I was born out of architecture. It's only technology is only 200 years old. If you go back to Sinan, you'll see, but all of you know, he was a client, a builder, an architect, an engineer, a maker, all these things.
And a thinker.
Exactly. So you cut slices, and I want to connect these slices back, which is why I do this.
And you said in your lecture, I heard that you said, I have the eyes of an architect as well.
Yes.
Can you describe what is it?
Yeah, I think that the eyes of the architect, the best architect.
I mean, what is the difference from the eyes of an engineer?
Yeah. Well, the eyes of a good engineer is he can see the load path quickly. He can see beyond your shape how he's going to get the load and how he's going to react to the wind and the earthquake very quickly. That's like 5 minutes for me these days, right? I know how to do that. But the architect's role is very complex because he has to deal with economics, sociology, ethnography, all these questions. Many of the less good architects have given this up by becoming artistic, so just doing a conceptual idea, or by becoming what I would call delivery architects. They're not designing for the bigger picture. So for me, that's what I mean, is that I try and find architects who I think have got a good eye already. I go and try and work with them, learn how to see things in their way, which is why I deliberately put Zaha Hadid and David Chipperfield projects next to each other. Okay. Because in the world of education, these two would never meet if you talk to architects, because it's stylistic. Yeah. One is that and the other is that, right? So you just don't know how to deal with it, but I deliberately place these things in order to uncover and be curious and then say, okay, I can think like an architect, I can see like an architect, I am the engineer, the best engineer, and I can make your project look better than you can. So all the good architects look even better when they work with people like me.
Sure.
This is the idea.
Sure, it's true. Yeah. So talking about the values of architecture rather than some values of engineering, maybe we can talk about a bit sustainability, I mean the ecological sustainability or economic sustainability as well. In these days in Turkey there is a debate or there's a discussion about the cities, how should be the cities, I mean, do you know any term like horizontal city?
No.
Have you ever heard?
No. I don't want to live in one if there is one.
Where is this?
I don't know where it is.
Okay.
So in a way, I find referring to cities and technology and constructions in these simple terms is simplifying, again, your discipline. Yeah. You are not engaging with the reality of life. You can't make these decisions that simply. So I was very deliberate in saying I'm going to talk about vertical systems.
Okay.
And I was talking about horizontal systems.
It's a bit dangerous to talk about vertical systems in this country.
Why?
I bet you don't want to learn this.
Okay. But I would say to you that I think that the small footprint, first of all, density is not going to go away. Cities are not stopping. While we all consider whether we should do our city or not, there are 400 being built in India the size of this. Secondary cities. So the mega cities in India are already 24 million people already. So there are 400 cities that have 15 million population already in India. So we are like you and us, even London, are a small part. The density is not going away. And one of the most ecological ways is to concentrate the footprint.
Really?
Yes, definitely.
I mean, nobody believes in it.
But I know, as long as
because we like sprawled cities, I mean, horizontal cities with gardens. Everyone has to have a garden.
I'm not saying that you don't do that.
Okay.
But I don't think the whole city needs to be like this. I think there is a mistake, certainly in London, where we have allocated certain areas for tall buildings and design district, commercial district. This has killed the city a little bit because like where I'm working in Old Street, where we have all the creatives, one of the reasons I created my office there was if you draw a mile radius, it has the most architects in that area. So I have to go for a sandwich and I will make a new client in the street. And they have to go for a sandwich and they will meet the engineer who makes their dream come true. So in a way, I think this idea of actually, that's an old city. And it's a mixture of Adobe and, Media City. All of us are in these buildings that are there. But when you go to specialized areas where you fix tall building only in certain areas, I think it creates an inequity.
Okay.
A formal inequity, a financial inequity. And as we are learning in London, it is a big problem. And every city is now learning this, that investors are putting money, it's a gambling idea. Our planning officer said it's a bank for people to wash their money. So there's these issues that are coming up that I think are, let me call them the enemy of modernization. I think it is risky to not modernize. Modernization and progress is our responsibility. You can't do it in the way that everybody does it. So there are lots of ugly towers. I showed some of them.
Yeah.
But you must not abandon the tower, and you mustn't abandon the ground scraper. You have to think. Sprawl is a car culture. Sprawl grew out of cars, if you look back at the American cities. And I do think that the difference between, mid-rise, dense places built together like here, then sprawl is a big difference. And I'm anti-sprawl. I definitely do not agree with this condition at the urban edges.
Okay, maybe in that sense we can talk about, I like the word of superimposable.
Yeah.
I mean, when you use this word for the cities, I think you're defending the idea of not having the zones of tall buildings and zones of horizontal developments. So in that sense, London is a very interesting example of in the world, as well as I see. But what I saw in London, in the ground floor, all the city is like accessible. And you can walk, and then you can enter to all the buildings. There is no barrier. Yeah. I mean, there are no much, let's say, gated communities. Even in Mayfair, for example, where the most wealthy people are living, you can go to the door of somebody and then knock the door without any policeman or without any security people.
Yes.
So what do you think about the new developments going on in Dubai, in some eastern cities, having lots of security and lots of barriers, walls and everything, including Istanbul, for example?
Well, I think it's cheating the public. So in terms of moral and ethical position, the ground belongs to nature and urban systems. These are siblings, the urban systems and nature. And the public and everybody has the right to the ground. So if you can free the ground floor of your building, and I showed in Bloomberg, this was a big conversation from two rich people, the architect who wants to be a developer and the developer who wants to be an architect, having this conversation and freeing the ground. If you go to Bloomberg, even though it's a high security building, they spent a lot of time saying, okay, there is levels of security.
Okay.
Public can come in. Art is for everyone. You have to invent art for our space. And they freed the ground floor completely. So I feel that from that position, it is important as cities become dense and the overlap between, or the superimposition between infrastructure and freeing the space is growing. And especially if we begin to get rid of the car from these cities, which will come.
Yeah.
It will come. There will be less cars in the future. So I think that for me, it's not a good idea to own the ground. I think it's for the people.
Yeah. In that sense, maybe I can ask this question without any limit. What do you think about Wessel as an architectural piece, or as
Which one? Sorry.
Wessel in New York that you were contributing? Not as a
No, I will be
engineer.
honest.
I mean, maybe
No,
you can answer as a
no. I will
an
explain.
architect.
So sometimes you do a project purely for the profit. There's big profit in that project.
Is it profit of public or?
No, profit of the engineer and the architect.
Okay.
So you have to understand that everything around it is largely ugly. I mean, not bad, but it's not good. And it's modern, a little bit like your airport. So you got this situation where, well, I'm not saying it's bad, but I'm saying it's average and it's homogeneous, right? And this new development in Hudson Yard is the largest piece of land, and we have the same in King's Cross. So it's not bad, but it's average. You could have put a little bit of effort. Now, the problem with the vessel is that, first of all, it was an art competition.
Okay.
And it was an idea by the client to increase the value of his property. And he and other clients say that if I get an art piece, people will come. They will even buy coffee from an art piece if you put Starbucks on top of it. But buildings, you know, they come or not, I don't really think it's important. So he ran an artistic competition with Anish Kapoor and a number of people. And we invented this idea because we thought, you know, we're not going to compete with Kuhn. We're not going to compete with Anish Kapoor. What can we do that has a material, architectural, engineering idea about it? I have to be honest, when we won, we didn't think anybody would build it. But somebody decided to build it.
This is US. They
Yeah.
built everything.
They built it. We didn't think necessarily it was going to be built. But I'm pleased it got built. I'm pleased because in many ways it's questioning what is architecture, what is public space, and what is the purpose. Because if you listen to Thomas Heatherwick talk about it eloquently, he himself says that sometimes it doesn't have to have a purpose. If it improves the quality of the development or life, it can be an object. And he talks about it like that.
Sure.
But, you know, there is a health equation. So in America, they do need a lot of exercise. We know everybody needs exercise these days. So the steps are actually quite a challenge for people. And people love going there and trying to climb in these things, which is better than just doing art for the sake of art, I guess.
Okay, what do you think about New York, for example, in that sense of sustainability
I think,
and sprawl or vertical or horizontal?
It's difficult because in the invention of a city that is only 100 years old, I don't know how else they could have done what they've done. So I think it's a very successful city. I think it's very amicable and you know, comfortable, very secure because it's dense. So there is an example of extremeness where you have density on towers everywhere, and yet the communities are still overlapping. Where I find it difficult is that the ground plane and, you know, the lower levels destroy the climate.
Yeah.
So it is an artificial climate, air quality isn't good, and it's not accessible to the poorest people in the world. So these are issues that I think, if there were lessons to be learned from projects like that, is how do we avoid that? And one of the answers must be to retain public space within these clusters. Don't stop the clusters, but you create a situation where...
So you don't believe that density is an enemy?
No, definitely not. No,
yeah.
I think it's an ecological solution.
The important thing is the quality.
Yes.
If it's a qualified density, there's no problem
Exactly.
with that. Okay. Maybe we can ask some for some questions from the hall.
Brave girl, one there.
Mikrofon verilecek herhalde değil mi? Yes. Bir de kendinizi de tanıtırsanız.
Hi, firstly, I want to thank you such inspiring speech. My name is Ebrar. I am a third year interior design student. I want to ask you about what you think the academy's education, which include your speech, kind of the interdisciplines and collaboration. I have no idea, do you have any idea about the Turkish academy, but we have such strict boundaries that even architects has no idea about the interiors, even engineering student has no idea. That's why there's a such big conflict when we complete our education, like especially at the side, that we have no idea how to work together. I should think that instead of those strict boundaries, we have collaboration design studios. Also, sorry for that, but this is my really openly feeling about our design and history courses, that I'm really tired of repeating Bauhaus hundreds times. There's no purpose repeating Bauhaus. What you're gonna try to teach us, not teaching Bauhaus by doing, always repeating with PowerPoints. So what do you think as an academician to revise the education?
So I think I agree with you completely, because for 25 years, when I started the office, I learned that the education of an engineer actually was terrible, because I had never been taught how to stand up and talk about my work. I spent 4 years doing calculations, physics, all the time. When I left university, I spent another 2 or 3 years trying to become an engineer, get a qualification. In no point was I communicating with an architect or a city planner or anybody. So engineering education is much worse than architecture, believe me, and we are not taught how to speak. So one of the reasons I entered academe is really to understand communication tools and how can we collaborate through communicating linguistically, but also technologically, and also what are the other things you think about. So first point is that. The second point is, I think that the architectural education has also lost the plot, in the sense that they have abandoned some of these things, and some universities have gone too far into technology, to a point where they invent new ideologies, which we all know about. I call it geometry, but they call it something else. So, you have all these, sorry?
Acrobacy.
Yeah, exactly. So what has happened is that instead of abandoning the true kind of, you put it very well when you say that the boundaries have become borders. I said in my lecture, I see the boundary as the opportunity where you can feed through. It's the only place where real invention happens. And to do that, I think you have to put a new roadmap for the education of architects, definitely. And I've been doing that for 25 years. And also, from different parts. So AA, Stockholm, and then the USA. So I do believe that there is an opportunity now, with the current attention to ecology, the current attention to gender bias in our industry, the current attention to pluralism, and trying to break the kind of difficulties that are being created by monoculture. These are opportunities for architectural schools. I'll just give you one quick example. My studio in spring is going to be looking at the aesthetics of timber, not the manufacturing, not the rules, but what is the metabolism of aesthetics when you do timber buildings? The Japanese do it very well, but it is very Japanese, right? So you have to rethink, how do we rethink this idea? And this is an idea where I'm going to try and make, again, the question about bringing construction, but also aesthetics back into the discussion, beauty back into the discussion, and allow the conversation then to be punctuated by a symposium. So it will be an option studio, but in the middle of the offer, we're giving a 2-day conference on the subject, because I think that they don't learn unless they also hear the enemy in a way. So we're inviting a lot of people that we don't like to come and talk to our students, and so they can see why they are right in some place and some place we're right. I think this is pedagogical model that are being worked everywhere, and your education system needs to learn. Instead of copying, instead of replicating what you see on Instagram and on magazines, you need to look at a bottom-up way of learning and thinking. And many of you need to learn a little bit about engineers so that you don't listen to them when they say no. You fire them, and you find new ones that will say yes. And there are some, even in Turkey. So there are engineers who are rethinking also their own discipline.
So maybe I can interrupt for a moment the whole and then ask this question. You mentioned about timber structure or timber itself. What do you think about the future, I mean the near future of timber structure when we think about the problems of concrete and problems of steel in the sense of ecology and the carbon emission and the others?
Okay, so I believe, I mean, one of the reasons I'm doing the timber studio is to give concrete more time. I believe concrete is going to solve its problem. It's just a question of time. Scientists and engineers, one thing they do well is when they know the problem, now they know the problem of carbon footprint. There are many concretes being invented. We're just testing something that's carbon capturing. It will be only a matter of 15 years before concrete regains its reputation. And in any case, it's not going away. 60% of the world is built with this material. But the problem I have is this has been hijacked. So every architect is being told, you must design in timber. It's ecologically the best thing to do. And then the architect is wondering, what should I do? And the client comes and fires him because there's a timber special architect. There's an architect who claims to be the world's expert on timber. So he's slicing even more. So I want to question this idea about the industry and forestry and sustainability in timber. I want to say that with mass timber and engineered timber, which is ecologically better, how much of the future world can you actually build? Don't pretend that all buildings suddenly. And then how do you overlap? So we're looking at tall timber, adding them on top of concrete tall. So we can make them even taller. And this can be a different kind of conversation. And then looking at the skin in timber, how can we make it more waterproof, long life, you know, these things. So I think there's a very optimistic about timber, but right now it's been driven by fashion.
Okay.
Too much.
This fashion didn't come to Turkey right now.
Yeah, okay.
It's a very old fashion in Turkey. So how it's come?
And if we are the generation of architects or architectural thinkers or whatever, we saw engineering in the personalities of Felix Candela and Santiago Calatrava, Pierluigi Nervi. They were a group of engineers, but they were almost equally talented as the architects. You know, they went over that. And I have been observing you as a professional, and this speech is also very enlightening. You have never uttered the word I. You always said we. So I saw a sort of commonality of a mission that is architect, engineer, client, user, and whatever. My comment is just to appreciate that. There's no question about it. But this is a new generation of engineering which will really shed life and light into our profession. And I thank you for that.
Thank you. I want to say something about what my office thinks. We in the office have a big debate about Calatrava, because there are a lot of people in my office who like him. He's the Manta Ray in my world. So he can't fly and he can't swim. If you look at his architecture, it's really bad. He used to be a good engineer once upon a time. So I'm very conscious of this I-ness and this thing where architects claim to be engineers, but if you look back what they actually built, 2 roofs. You know, today, engineers need to be building cities, not one roof, you know, and then write a book about the roof. There are engineers like that. There are engineers who are entering, I call them archineers. You know, they enter this world and they want to take over the architect's role and so on. So you're right. If we don't do the we discussion, and in that we discussion, the technologist has to be the technologist. He just has to bleed when somebody hits this guy. I should bleed as well. That's the empathetic idea that I think has created some of the work that my office produces. And we have a lot of people in the office, funnily enough, a lot of females. Not enough of them. A lot of females have always thought like this in my office for some reason. So we're beginning to learn about ourselves and how to change this again. It's very important.
Yeah, but I mean, the communality was great. I mean,
Yeah.
it's very different than the old generation, than the other generation.
Yeah.
You're not too young, but
No.
you're behaving like young people. Okay.
I'm impressed that everybody's still awake.
Of course.
It's good.
But it was a really inspiring lecture.
It's good.
It's not very easy to find it in these days.
Can I ask a question?
Yeah.
Thank you for your speech and your great conversation. My
No, no.
question is...
Sesinizi biraz yükselt.
Thank you for your speech and your great conversation. My question is actually about a recent building, which is called the vertical forest. So you talked about the density of a city and how it can be a good thing if it's a qualified density. Do you think having a green area within a vertical space would make the density a bit more qualified?
I think that there is some element of fashion in putting green. It's like buying an American Hummer and then painting it green and calling it sustainable. It's not. It's a misinterpretation of sustainability. But when you look at the real buildings, like architects in certain climates are doing quite a lot of these now, in Singapore, in Bangladesh, where they know the climate and they know their problems, and they're bringing greenery into, and it can grow in these places, not just for the ecological conversation, but biophilia. You know, it makes you feel better. You feel better quality of life in a way. I think this is a move that I'm seeing quite a lot in some projects, introduction of this. And I think it is interesting that in London we have only one large building, which is called the walkie-talkie, where the shape is made because of that excuse. The excuse was we can put a green public space on the top. That to me is like buying a Hummer and painting it green. Because I think people can't go in there easily. It is not big enough for a public space like it would be on the ground. So I think there's degrees of truth in this world. I do believe in certain climates it's important, and I just tell you to refer to the Sharjah Triennial, which was just happened just now, with curated by Adrian Lahoud for the Sharjah Art Foundation, which was about the rights of the next generation. And the project I did there was a garden with a small group called Cooking Sections. And our garden is really about how can you grow desert plants, indigenous desert plants that don't need water. Now, if we are successful, we're going to measure this over 3 years. With this experiment, this to me should be in every property in Dubai.
Okay, one last question, please. There are lots of questions, but I think we have to terminate.
Where's the microphone?
Hi, thank you for being here and for your speech. I really like to ask you that, was it, I mean, I sense from your speech that you care about innovation and creativeness and all the stuff more than profit. But was it all like this? Because in this room, lots of people are just students and they are like at their survival stage of their lives. And I really want to know about what was your inner motivation from the beginning? Not like for now.
Okay.
How did you become Hanif Kara? I really wonder this.
Okay, so I was young once upon a time.
Yeah.
And I was a migrant from East Africa that went to the West. So I had my young growing up stage in a very bad place of Africa, where the issues that you are now talking about, climate emergency, all of food certainty, was really visible in that part of the world. So my inner motivation has been being fearless, because when we left the country and went to the UK, I promised myself that I would educate myself to a point where nobody can actually allow me not to do what I want to do. So the motivation has been wanting to take a risk all the time, being fearless. And I would say to you that I can do these lectures, right? I have many ways of talking about them, and I can show projects that are all only about function and how we improve the function from a normal school to a better performing school, or a hospital or a laboratory that won the Sterling Prize, because normally it doesn't. So I only deliberately chose this group of projects and the subject of innovation today. But when I'm really practicing at work, and if you look at the nature of the work, the motivation remains the same, which is my daily life. I like to wake up early, and I want to go to work, and I want to build better buildings all the time. And I'm challenging even the younger people in my office, believe it or not, by asking some of these curious questions. So curiosity, fearless, and not being afraid of being poor again.